oh, no, these are just children's books that we use, even with our high school and our university students, because they're quick and they're interesting, and they make the point quickly, and they capture kids' attention. I'm not going to show you.
What's engineering?
Yeah.
But at the end of the day, we're going to give you a website that have all these activities and many more, because we obviously don't have time to do everything.
All right, so when we talk about science, oftentimes when we do workshops with science educators, university professors, teachers, in the science community, words are thrown around, and people mix them up all of the time. But there are science is one thing, scientific inquiry is another, is different. There's certainly mathematics, there's problem solving. Engineering is what we think is where all of these things intersect. So if I wanted to think about the best place to integrate science and mathematics, it would be through inquiry and problem solving experiences wrapped around an engineering project or an engineering theme. In the United States, we are coming out with brand new science standards. Norman mentioned that this morning. And for the first time, they're including engineering and engineering practices. So every science classroom in the United States, regardless of whether it's biology, chemistry, physics, earth science, astronomy, oceanography, will also have to have some components of engineering built in, because they see that the science content that you're teaching would just be concepts and words unless you can apply it through problem-solving experiences, and it's engineering where they actually work themselves out in the most authentic ways. The other thing that they put into the science standards is mathematics, and the place where mathematics intersects science. So science teachers in the United States are all, well, they're very nervous all of a sudden, because they were just learning science and they were trying to do inquiry and trying to get a handle on that. And now there are all of these other pieces that they're going to be required to do. And the assessments are going to also be matched to teaching science, but incorporated and integrating mathematics and engineering, as well as inquiry into the science classrooms. 46 states have adopted these new standards. And so if they come up with a common assessment, we don't have a national exam, but if they come up, and 46 states out of 51 are all going to be accountable in taking this test, it's going to be pretty close to a national exam in science. So things are shifting, but engineering is where we see we can get all of these things in. Because there's still more stuff. Nobody added time. Nobody added more days. Nobody added more teaching time. You have to do more in the time that you have. So you have to integrate. So earlier this morning I asked, what is science? You remember. And that was one of those questions everybody went, oh, I don't want to answer that question. Is this one easier? Does anybody want to tell me what they think the answer to that is? Well, there's a lot of different answers to this, all right? The American comes out of the practicing engineers has this definition. You can read it in Chinese. Oh, they have it there, but it's not. But it's in English there too.
Yeah.
But you don't even have to read it to know that it's big. All right, it's complex. If you were a classroom teacher, you had to teach engineering. This is the definition. You quit. Then, if you ask for the simplest one, it's this: the science of building useful stuff using science. That's pretty small. And this isn't sufficient either. As a teacher, this helps me no more than this one. Right? They're both bad. They're both useless. They may not be inaccurate, but they're useless. So, here are some other definitions. And this, I don't know why the bottom one is sort of cut off, but the discipline of acquiring and applying scientific and technical logic to technological knowledge, design analysis, and/or construction of works for practical purposes. The discipline that deals with the application of scientific knowledge to solve practical problems, or methods related to the practical application of mathematics and scientific principles to the design, construction, and operation of structures, equipment, and what's the last word there? It didn't come out?
Yeah, if you,
Yeah, I know I can do that, but I can get a copy here. But as you look at these, is there one definition you like better? Of these three? These are sort of in the middle between the little simple one and the great big complex one. There are three different definitions. These are not the same. There are three possibilities.
前面有一个很复杂的定义，然后后来秀了一个就是一行字的这个定义，那他觉得事实上这两个定义对老师来讲没有太大的用处。那他现在这一篇呢列了3个可能的定义，就是大家觉得这3个定义哪一个最符合你对engineering 想法的定义这样子，最符合在这个领域的觉得这样领域的特性。 最后一排字被切掉，需要翻译吗？应该的。
The bottom one, it says operations of structures, equipment, and systems. Is there one you like better?
You want?
Yeah. And it doesn't make any difference. It's the one that works for you, because they're all correct. It's the one that makes sense to you. And because you have to interpret this into practice in your classroom if you're teaching engineering. So it has to be the one that makes sense to you as you either create or implement your curriculum. So how many like this one? How many like this one? And what about this last one? Okay, so it's a pretty mixed vote. Some people fail. There's nothing going on. Okay, so yeah. Some people like this last one because it specifically says mathematics here, okay? It specifically says science, and it says the application of these things, and it includes the word design, construction, equipment, and that last word that you can't see is systems. And systems is oftentimes the operative word to show not only the integration, but the interdisciplinary connections between those integrated things. So systems dynamics is one of those pieces of engineering that is often forgotten when we talk about science. When we talk about science, we talk about the concepts in separate ways. We don't often talk about the interplay between them. And that's the important part of adding the engineering piece, I think, to our curriculum. Kevin is an architect.
Yes.
You can't think about building anything without thinking about the interplay of all of the components.
Sure. It's systematic quick problems. Systematic system.
And I think that that's the thing that you can bring to your students that they're not necessarily getting in other classes. So I'll let you interpret that.
那刚才他的这一段呢，就是说明了这3个定义其实都没有错。那大家可以根据自己对这3个定义的认识，然后去应用在你的课程里头。好，那他最后好像有特别问到赖老师关于他选的是最后第3个哈，第3个。那当然这里也强调的是，我想讲者也是比较喜欢第3个也许第3个定义是有谈到了科学、数学，还有比如说工程的建筑和操作应用，以及一些工具系统化的东西。那这是他刚刚稍微讲。
So I think for a teacher, you choose the one that makes the most sense for you because you're the one who's going to be bringing the interpretation of that definition to your students. And sometimes it's difficult to define something. Sometimes it's easier to get the students to understand what something is by the way it's done. So we also talk to our students not only about what is engineering, but what do engineers do? Because that also gives them a better idea of engineering. In science classes and physics, when I was a physics teacher, I had to talk about energy and energy systems. It's really hard to talk about energy, heat energy, sound energy, light energy. But when you started to talk about the effects of them, or how one plays itself out. If I look at light and examine light, I have a better sense of light energy. If I look at, if I think about watch things move, I get a better sense of mechanical energy. So sometimes it's easier to see the end product to understand what something is, as opposed to being able to wrap a definition around it in the front pocket.
他在除了讲前面的那个问题，就是问什么是 engineering， 然后接着他会问的是那 engineer 会做什么？不知道这样怎么翻译？工程师会做些什么事情，让学生比较能够想象在有一个比较完整的想法，关于人他会做是这样从事这样工作的人，他们做些什么事情。那他举的一个例子是他曾经教那个物理课的时候讲到能源的，那能源有很多种类型，对学生来讲是很抽象的，所以他会用一些比较具象的方式，比如说它的能源产生的效果是什么等等，从那里去引导。
You also choose those definitions of engineering. You choose the ones that fit the developmental appropriateness of your students. If you're teaching young children, this may be the best definition for a primary level child. This might be useful for a university student. And these are probably the most useful for middle and secondary level students. So you use the type of definition that best fits the age and the intellectual capabilities of the students. The same with what do engineers do. Engineers use scientific discoveries to design products and processes that meet society's needs. But you can go on to say using math and science knowledge and ingenuity in practical ways, they invent and create the most reasonable physical advancements to improve quality of life. This is I like this definition because of this word reasonable. That reasonable word is what makes engineering different from science, because when we talk about engineering, we talk about two pieces that are not always involved in scientific inquiry and investigations, and that's criteria and conditions. We'll talk more about those. And those conditions add constraints. So it's criteria, conditions, and constraints that are added pieces when you think about real-world engineering projects. And we also talk about, in general, engineers make the stuff of our lives better, easier, cheaper, more efficient, more fun by solving everyday problems. What was it? Sunday, Shane Yo and Kevin and I went to the old town in Tainan. And we went into a place that showed Aboriginal Taiwanese, and they had them hunting. Okay, they had clothing from, they were weaving cloth. They had pots that they were cooking with. They had bows and arrows. They had homes that they constructed. And the word was primitive Aboriginal. And I said, how wrong is that? These were people at that time who solved their needs with the things that and resources they had available to them. That's not primitive, that's smart. What did I say? I said, someday, maybe 200 years from now, people are going to look at us and say, look at those primitive people from 2013. Using those stupid computers, these big things. Okay? We can't use that lens from the future to look back and say they were primitive. They took weaving, they had a loom, they were making clothing from the plant materials they had. They were coloring it with dyes. This is advanced technology for that time. And I think that that's a better way to interpret technology and engineering. It's solving the problems that you have now with the stuff that you have available, okay, in new and different ways.
稍微解释一下，这个情境秀的昨天嘛，那前天我们就是去逛台南老街，
德基洋，
对，德基洋行里面它有展示，然后里面刚好有一个原住民的那个早期的人类的生活的一个那个展示，然后他就举到那个例子，他就特别对那个原始的这个字很有意见，所以他觉得说，如果200年之后的人看我们现在，可能我们也是被冠上那个原始的生活方式这样子，好，大概就是一个情境这样。
Something that's interesting, I think in Pintong you have the cultural museum too. Mm-hmm. Okay, and so one of the things that always interests me when you see these dioramas, these depictions of people from other times, especially when they call them primitive. And they're wearing jewelry. All right? In Ping Tong, I know they had, the men and the women had earrings and bracelets.
Yeah.
What purpose is that?
Decorating?
Oh, yeah. It's not making my life easier. I'm not planting food. I'm not killing animals. I'm not sheltering. It's decoration. It's art with the things that I have. That's not just living from day to day. That's having some free time. That's being a human being and expressing another whole side of being a human. And jewelry is technology. Jewelry is engineered to fit and to be worn and to decorate yourself and have an artistic expression. Sometimes we just completely forget all about those things. You know, I think more fun by solving everyday problems means how can I look better? Maybe, I don't know. But it's something to think about when we look at engineering and technology and the things that we create.
他就举了一个在屏东，他看到一样会有一些展示啊，他提到的就是你要去做
琉璃珠。
琉璃珠的，那他把那些事情都视为都跟我们的艺术有关这样子，这个就是生活当中去寻找要解决的问题，那他也许有些问题，不见得就是只是生活好，对，只是生活便利，他可能也有一些问题是怎么样让我们自己变漂亮也行啊，哈，就是有一些这些都在他的在他的那个范畴里面，都跟今天的主题有关。
So the next thing we have our students do is just look around the room they're in. Okay? And I want you to do this. It's a scavenger hunt. You know what a scavenger hunt is? Find as many examples of engineering. So if we go back to this list, okay, look around this room. You can get up, walk around, and make a list of all of the engineering and technology you see. Go.
好，接下来这个活动，他在这间房间里面找任何你认为是跟工程跟科技有关的任何东西，然后写下来，OK，然后现在就可以动作了，这样，这是一个小小的活动。
Okay, you got like 5